Dear students, today we will start Module 4. What is Module 4? Module 4 contains vector spaces and orthogonality. Vector space. The definition of vector space is a real vector space is a set of vectors together with rules for vector addition and scalar multiplication. A real vector space is denoted by Rn. Here R is a real vector space and n is a dimension of the vector space. The dimensions is 1, 2, so on up to n. Then the subspace. What is subspace? The subspace is a vector subspace of a vector space is a non-empty subset that satisfies the requirements for a vector space. What are requirements for a vector space? Linear combination must stay in the subspace. Linear combinations of that vector space must stay in the subspace. Next one is column space. Column space is denoted as C of A. The column space of a matrix A is the linear combination of the columns of A. Linear combination of the columns of A here, C of A, column space of A which is equals to x1 v1 plus x2 v2 plus so on up to xn vn. Here x1 is the scalar unknowns, v1 is the vectors, v1 v2 vn are the vectors. Okay. The null space which is denoted by n of A, the null space of a matrix A is defined as the solution to the matrix A and the vector matrix X which is equals to 0. The null space is a solution of AX which is equals to 0. The null space of a matrix consists of all vectors which is matrix X such as AX which is equals to 0. So now we will see one example on this column space and null space for the given matrix which is A 1 minus 1 0 0. First we find the column space. How to find column space of A which is equals to linear combination of the column vectors. Linear combination of the column vectors. Column vectors are 1 0. One vector, first vector is 1 0 and second vector is minus 1 0. Here linear combination is x1 into the first column vector 1 0 plus x2 into the second column vector minus 1 0. This equation is also written as in terms of it spans the column space. These two column vectors. Column space which spans these two vectors, column vectors. Next we will see how to find the null space. Null space n of A which is a solution of AX which is equals to 0. Here A is the given matrix and X is the vector contains x1 x2 which is belongs to the real vector space. Therefore A is the given matrix 1 minus 1 0 0 and X is x1 x2 which is equals to 0. Multiply these two matrices, we get x1 minus x2 which is equals to 0. Here x1 which is equals to x2 which is equals to some constant c. Therefore the null space n of A which is equals to x1, the column vector containing x1 x2 which is equals to x1 is x1 x2 some constant c which is equals to C into the column vector containing 1, 1. Here C is some constant. This is the null space for the given matrix. So now we will solve this problem. Determine the column space and null space of the given matrix. Matrix B contains 0, 0, 3 and 1, 2, 3. Here the column vectors are 0, 1 and 0, 2 and 3. Therefore, here we have 3 column vectors. Find column space. Column space is linear combination of these vectors. Linear combination of column vectors. Linear combination is x1 into the column vector. Column vector is 0, 1 plus x2 into the column vector 0, 2 plus x3 into third column vector containing 3, 3, which is also equals to span of these 3 vectors 0, 1, 0, 2 and 3, 3. This is our column space for the given matrix B. The matrix is B. Column space for the matrix B. Next we will find null space. Null space, which is denoted by n of B, n of the given matrix, and which is the solution of Ax, which is equals to 0. The solution of Ax equals 0. Therefore, here A is the given matrix, which is B, Bx, which is equals to 0. Here B is 0, 1, 0, 2, 3, 3. And x1, x2. So multiply these two matrices, we get 0x1 plus 0x2 plus 3x3, which is equals to 0. 1x1 plus 2x2 plus 3x3, which is equals to 0. From this we get 0x1 0 0, 3x3, which is equals to 0, which implies x3 is equal to 0. From this we get x3 is 0. Substitute in this equation, we get x1 plus 2x2 plus 3 into x3 is 0, which is equals to 0. Therefore, which implies x1, which is equals to minus 2x2. Here we take x2 as C. Let x2 is C. Then we get x1 as, which is equals to minus 2 into C. Therefore, we substitute x1, x2 and x3 values in the null space of B, which is n of B. We get x1, x2, x3, which is here x1 is minus 2 into C. Minus 2 into C. And x2 is C. And x3 is 0. x3 is 0. 0. Therefore, we take C common. Then we get n of B, which is equals to C into, we take C as common, we get C into minus 2, 1, 0. Is the null space of the given matrix B.